In last lecture, we have seen introduction part of carbon and carbon, how it is represented, what is the valency of carbon and what is meant by covalent bond. And we have seen that carbon will share its 4 electrons, and how to represent carbon we have seen. So whenever you take carbon with symbol C, and it has 4 valencies, 1, 2, 3, 4, and we have understood the meaning of these lines. There will be an electron at this end. It will be waiting for another electron to get bond at this end. We have understood what is meant by single bond in hydrogen, double bond in oxygen, triple bond in nitrogen. If there is one pair of electrons, one pair of bond between atoms, we can call it a single bond. If 2 pairs, we can call it as double bond. If there are 3 pairs, we can call it as triple bond. Next. Now, here we have a structure. Let us try to understand that structure and let us see allotropes of carbon. So first, if you observe this is known as methane. Methane. It is a carbon compound. How methane is formed? There will be one carbon and hydrogens are combined to the methane. How many hydrogens? Means 4 hydrogens. CH4 is the formula of that methane. I'll teach you today how to write that methane, 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 and what are those, that and all I'll explain you, such that you will be in position to write all carbon compound names. Methane. Now you see CH4. Now if they ask you to draw structure, so first what is their carbon? Carbon we know, and how many valence electrons we can represent? 4. 1, 2, 3, 4, and one carbon is combining with how many hydrogens? 4 hydrogens. There will be one hydrogen here with one valence electron of hydrogen, hydrogen with one valence electron of it, here one hydrogen with one valence electron, here another hydrogen with one valence electron. Now individually these hydrogens will share each electron from the carbon to get stable. Now if you observe the circle, in circle there will be 2 electrons. 2 electron in the sense hydrogen atomic number, now it has become 2. Of course atomic number will not become 2. It has 2 electrons such that hydrogen is stable. Here all 4 hydrogens are stable. And while coming to carbon, carbon can share electrons from each carbon such that if you observe this circle of the carbon, there will be 8 electrons in outermost orbit, such that 8 and remaining 2 electrons in first orbit, it will become constant and stable, such that CH4 methane molecule or compound is formed. If they ask you to draw electron dot structure, you can draw like this. You can observe carbon with 1, 2, 3, 4 cross marks. You can observe these cross marks are representing electrons of carbon, and hydrogen's electron is represented with dot. I told you, you can represent electron with cross mark or dot mark, either way. You can observe these blue color balls, which is representing hydrogen stability. This pink or rose color ball or circle representing carbon stability. So we have got methane CH4. We'll try to understand how to draw, how to name, how to go with a formula, everything in this lecture. And this electron dot structure, how can you represent in form of normal structure? Means C with 4 valencies and hydrogens here. That's it. Very simple diagram. Now what is the meaning of this? At this end we have 1 electron of carbon, at this end we have 1 electron of hydrogen. That is the meaning. Like this simply you can draw and you can leave. Next we have a concept, allotropes. What is meant by allotrope? If one element is obtaining in different forms. You see, the element carbon occurs in different forms in nature with widely varying physical properties. Carbon can be obtained in different forms with different physical properties. Both diamond and graphite are formed by carbon atoms. You see, diamond is formed by carbon, graphite is also formed by carbon. The difference lies in the manner in which carbon atoms are bonded to one another. Consider, we have one carbon atom, we have another carbon atom, like that we have different carbon atoms. How all carbon atoms are combined? If you try to understand that, then it will be easy for you to understand the structures. So why that physical properties and shapes are different means that difference because arrangement of carbon or carbon atoms are bonded to one another. In diamond, each carbon atom is bonded to 4 other carbon atoms forming rigid three-dimensional structure. You can observe this is diamond. In this diamond, you see one carbon. You can observe one carbon is bonded with 1, 2, 3, 4 carbons. And again, this carbon can be formed with another carbon. This carbon can be bonded like that. There is multiple bondings and one carbon is bonded with 4 carbon atoms and it is forming rigid three-dimensional structure. But in graphite, each carbon atom is bonded to 3 carbon atoms only in the same plane given hexagonal array. You can observe one carbon is bonded with 3. Here one carbon bonded with 1, 2, 3. Here one carbon can be bonded with 1, 2, 3. Like that, it forms hexagonal shape. Because of this structure in graphite, graphite is brittle. Brittle means weak, not so strong. But while coming to diamond, you see, it is so strong, isn't it? You can observe pencils. In pencils, they will use this graphite only. You can break it very easily. But while coming to diamond, to cut diamond, we need another diamond. That much strong is the diamond. Why we are getting weak objects or strong compounds, weak compounds? That is depending on structure and depending on bonding. These two are so important in giving strength of any substance. One of these bonds is double bond and thus valency of carbon is satisfied. Here carbon will satisfy valency of 4. Graphite structure is formed by hexagonal array being placed in layer above and above. Here there is one array, above that there will be another array, above that, like that. It will be arrays like this. Because of arrangement of this, it is so brittle. But here, because of the bond structure, bond angle, it is strong. Diamond is strong. These two different structures result in diamond and graphite having very different physical properties, even though their chemical properties are same. If you see, diamond is made up of carbon, graphite is made up of carbon. For carbon, chemical properties are same, but physical properties are different. Diamond is the hardest substance known, while graphite is smooth and slippery. Graphite is also very good conductor of electricity, unlike other non-metals that you studied in previous chapter. Metals and non-metals we have studied. Maximum non-metals are not good conductors of electricity, but graphite is a non-metal which is good conductor of electricity. Diamond can be synthesized by subjecting pure carbon to very high pressure and temperature. How diamonds are formed? If you observe earth crust, in earth crust, that carbon which is subjected to high temperature at the same time subjected to high pressure. Because of high temperature and high pressure, that carbon atoms will be squeezed, compressed, such that hard substance is formed known as diamond. The synthetic diamonds are small but otherwise indistinguishable from natural diamonds. Yes, we can produce synthetic diamonds also. which are small and weak. Yes, we can hit with a hammer such that those synthetic diamonds will break. But while coming to natural diamond, if we hit with hammer also, it will stay so strong. Next, we have another one, C60. That is nothing but fullerenes. Fullerenes form other class of carbon allotrope. The first one to be identified was C60, which is carbon atom arranged in shape of football. Since this looked like geodesic dome designed as US architect Buckminster Fuller, the molecule was named fullerenes. You see, there will be 60 carbons. 60 carbons are bonded to form a football-like structure, and this structure looks similar as US architect designed one geodesic dome. That scientist name is Buckminster Fuller. So in the honor of his name, they have made Buckminster Fullerenes as name of this C60. This is one of the molecules, that's it. Like diamond, how the structure for graphite, C60 is one of the structures and one of the allotropes of carbon. Here you can observe two in-text questions they have given. First one, what would be the electron dot structure of carbon dioxide which has formula CO2? So for CO2, we have to draw electron dot structure. So what are the elements present, atoms present? Carbon and oxygen. Carbon atomic number 6, oxygen atomic number is 8. If you write electronic configuration of carbon, 1s2, 2s2, 2p2. Electronic configuration of oxygen, 1s2, 2s2, 2p4. And while coming to valency orbit of carbon, 2s2, 2p2, valency orbit of oxygen, 2s2, 2p4. So for carbon, what we can draw valence electrons? 1, 2, 3, 4. Or here you can observe the structure, it is CO2. How many carbons? 1 carbon. How many oxygens? 2 oxygens. So simply to say, carbon can be written like this also, right? Carbon with 2 electrons this side and 2 electrons this side. Now oxygen. Oxygen, if you draw electron dot structure, oxygen, how many electrons? 4 plus 2, 6. 1, 2, 3, 4, 5, 6. Now they have asked for CO2. What we can do? CO2, there are 3 molecules. C, we can make it in the center. So if you make it C with 1, 2, 3, 4 valence electrons, this side we have oxygen with 1, 2, or else you can represent with the dot, 1, 2, 3, 4, 5, 6 electrons. This side also we have oxygen with 1, 2, 3, 4, 5, 6 valence electrons. Now this oxygen will share 2 electrons of carbon. This oxygen will share 2 electrons of carbon. And if you count the number of electrons in the circle, it is 1, 2, 3, 4, 5, 6, 7, 8. 8 is the valency octet rule satisfied. For this oxygen also, it got 8 valency electrons following octet rule got satisfied. And while coming to carbon, you can draw one circle which is sharing 2 electrons from this oxygen, 2 electrons from this oxygen. And if you count number of electrons in the carbon circle, 1, 2, 3, 4, 5, 6, 7, 8. It got 8 electrons satisfied. Like that, CO2 molecule is formed. If you want to represent in simple, C, this side oxygen, this side oxygen. How many pairs? 1, 2 this side. So double bond this side. How many pairs? 1, 2. So double bond this side. This is very simple structure of CO2. Like that you can draw it. Next, second question, what they have asked. What would be the electron dot structure of a molecule of sulfur which is made up of 8 atoms? Means you have to draw for S8. They gave one hint also. The 8 atoms of sulfur are joined together in form of ring. You know ring, which is in circular shape. Let us try to draw it. So how many sulfurs? 8. What is the electronic configuration or atomic number? Sulfur, chlorine, argon. Argon 18, chlorine 17, sulfur 16. So for 16, if you write electronic configuration, it is 1s2, 2s2, 2p6, 10, 1s2, 2s2, 2p6, 3s2, 12, 3p4, 16. That's it, right? 6 plus 2, 8, plus 2, 10, plus 2, 12, 16. What is the outermost orbit? 3s2, 3p4. 3s2, 3p4 means how many electrons? 4 plus 2, 6, isn't it? So how can we write? Yes, 1, 2, 3, 4, 5, 6. No problem, we can draw like this. Now, like that, 8 electrons, 8 sulfurs, which should be in form of ring, they told. Yes, 1, 2, 3, 4, 5, 6, 7, 8. Yes, we can write. So for this 1, 2, 3, 4, 5, 6. So here this 2 also you can arrange here 6. For this sulfur 6, no, 1, 2, 3, 4, 5, 6. For this sulfur 1, 2, 3, 4, 5, 6. For this sulfur 1, 2, 3, 4, 5, 6. For this sulfur 1, 2, 3, 4, 5, 6. For this sulfur 1, 2, 3, 4, 5, 6. For this one 1, 2, 3, 4, 5, 6. For this sulfur 1, 2, 3, 4, 5, 6. Now double bond between these two sulfurs, double bond between these two sulfurs, double bond between these two sulfurs, like that. Double bonds you can observe between these two sulfurs, like that. Yes, 8 or 6, 8 atoms can be formed. Simply to say, you can draw like this. For this sulfur, you can draw one big circle like this. You can count 1, 2, 3, 4, or else something like that it will form. So like that it can be formed. Or 1, 2, okay, let us find 4, 5, 6. You can see 1, 2, 3, 4, 5, 6 is also correct. There will be another sulfur 1, 2, 3, 4, 5, 6. There is another sulfur with 1, 2, 3, 4, 5, 6, because if you draw a circle, it is becoming 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons in outermost orbit, which is not octet rule, isn't it? So no double bonds. So you can draw like this: sulfur with 1, 2, 3, 4, 5, 6. Now, if you can draw a circle for one sulfur, you can find 1, 2, 3, 4, 5, 6, 7, 8. Now for this sulfur, if you draw, it becomes like this: 1, 2, 3, 4, 5, 6, 7, 8. For this sulfur, it is combining with another sulfur with 1, 2, 3, 4, 5, 6 valency. But if you draw like this, that can be combined. Like that, all 8 sulfurs will be in form of chain, and that can be represented like this: 3, 4, 5, 6, 7, 8 with all single bonds. Like that you have to draw. Next topic is versatility of carbon. So why carbon atom is so versatile in nature? Versatile means which has different properties, different capabilities, etc. We can call, if you consider a person who can sing, who can act, who can dance, who can paint, like that, if he has multiple talents, we can call them as versatile person. Like that, carbon is also so versatile. We have seen the information of covalent bond by sharing of electrons in various elements and compounds. So what is meant by covalent bond? Sharing of electrons. We have also seen the structure of simple carbon compound methane. So here we have observed simple carbon structure, carbon compound methane. In the beginning of the chapter, we saw how many things we use contain carbon. So we have observed in atmosphere 0.03%, on earth it was 0.02%. We have seen everything. In fact, we ourselves are made of carbon. That's what we have discussed. We are inhaling oxygen, we are exhaling carbon dioxide. We are made up of carbon. The number of carbon compounds whose formula known to chemists was recently estimated about 3 million. 1 million means 10 lakhs, 3 million means 30 lakh. Over 30 lakh carbon compounds are there on earth. Those many carbon compounds, those many formulas are there. So this outnumbers by a large margin compound formed by all other elements put together. Why it is that property is in carbon and no other element? So why only carbon can be found over 3 million objects, 3 million substances, and why you can see 30 lakh carbon compounds? Why we cannot see this thing in some other element? Means the nature of covalent bond enables carbon to form large number of compounds. So because of the covalent bond enabled by the carbon, whenever carbon want to get stable, it can share its electron to other element. Now because of the covalent bond only, these large number of compounds you can observe. Two factors you have to notice. What are those two factors? Guys, so important question, they have asked you twice, thrice in your board examination. Question is, why carbon is so versatile in nature? You give your answer in 2 sentences or 2 points. If they ask for 2 marks, what you have to write? Don't write this big paragraph. Let us check it. Carbon has a unique ability to form bond with other atoms carbon, giving rise to large molecule. Why? This property is called catenation. You have to write this point as 1 point. Carbon has property called catenation. What is that catenation? These compounds may have long chains of carbon or branched chains of carbon, even carbon atoms arranged in form of rings. So you can find long chains. Chains means which will be in straight line. Branched chains means like that, chain by chain we can find. Or you can find in form of rings also, like that. Carbon compounds can be arranged. In addition, carbon atoms may be linked by single, double, triple bonds. So carbon can go with single bond. You take oxygen, it can go with only double bond. But carbon, it can go with single bond, double bond, triple bond. Compound of carbon which are linked by only one single bond between carbon atoms are called saturated compounds. If they ask you what is meant by saturated, you have to go with this line. Compounds of carbon which are linked by only single bond between carbon atoms. So whenever you find structures, I'll show you structures here. You can find this structure now. This is step 2, or you can find this structure. Here you can observe between carbon and hydrogen we have only single bonds. One line here, one line, one line, one, 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 one. We don't have any two lines. So such type of compounds are known as saturated carbon compound. And if they ask you what is meant by unsaturated, what you have to say? Compounds of carbon having double or triple bonds between their carbon atoms are called unsaturated carbon. So if you observe this diagram here, in between carbon, how many lines? Don't call it as lines. From now, let us call it as bond. How many bonds are there? 1, 2. So it is double bond, unsaturated. And I'll show you another one. Wait. Here also you can see between carbon, of course we have single bond. At the same time we have double bond too. Single bond, double bond. So whenever you find at least one double bond, you can call it as unsaturated. Not only double, triple also, guys. Wait, I'll show it. So can you see here this structure? For this carbon and for this carbon, of course there is single bond, but for this carbon and for this carbon, in between these we have 1, 2, 3, isn't it? 3 bonds you can find. This is unsaturated. Here you can find double bond, here you can find triple bond, and between carbon and carbon you can find single bonds. Here you can find between carbon dioxide you can find double bonds, like that. Single, double bond, single, double, triple bonds you can find it. So from this context, what we can understand? We can understand that there are 3 bonds: single bond, double bond, and triple bond. Whenever you see, guys, 99.9, not 99, 100%, This single bonds should be between, not only single, double, triple, should between carbon atoms only. So single bond between carbon, double bond between carbons only, triple bond also between carbon. So single bond we have to call it as saturated. Double bond and triple bond we have to call it as unsaturated. So first of all, try to understand the meaning of compound. What is meaning of compound? Compound is nothing but combination of atoms. Atom, here another atom, here another atom. These atoms should be different, right? Atom should be different. Now, if one of the atoms is carbon, in these 3 or 4 or 5 or 2, if one atom is carbon and another thing, maybe some other atom, we don't know, maybe oxygen, maybe hydrogen, maybe sulfur, chlorine, bromine, iodine, etc., then this compound is known as carbon compound. That is the main difference we have to understand. So what is difference between compound and carbon compound? Normal compound, there will be combination of 2 to 3 atoms, different atoms. What is carbon compound? In that combination, one of the atoms is carbon, then that is carbon compound. Now, carbon compounds are divided into 2 parts or 2 categories. First one, saturated carbon compounds. Second one, unsaturated carbon compounds. Simple. So what is saturated? If there is single bond between carbon, saturated carbon compound. If there are double bonds and triple bonds between carbons, we can call unsaturated carbon compounds. Now I think so you got some idea. Next, no other element exhibits the property of catenation. So catenation means which should be in form of long chains, bond with other carbon. Here catenation means bonding with similar atoms is called catenation. Here you can observe sulfur. This sulfur is bonding with identical sulfur. This sulfur is bonding with the same sulfur. Like that, if identical atoms are combined to form long chains known as catenation. Don't forget about that. Catenation means identical atoms are combined to form long chains. Here sulfur has catenation. Sulfur is undergoing with catenation. But while coming to carbon, how many carbon chains we can draw? Let us see here. Take carbon. Valency 1, 2, 3, 4. Or okay, let us take carbon. Valency 1, 2, 3, 4. Guys, if I am drawing like this, you have to assume this carbon as 1, 2, 3, 4 valency. This carbon 1, 2, 3, 4. Now the meaning, this electron combined with this carbon. That is the meaning. Again carbon 1, 2, 3, 4. Yes, we have to include this. We have to count this. This carbon 1, 2, 3, 4. Carbon 1, 2, like that. How many you can find? You can write very long chain, or you can draw like this also. Carbon double bond, carbon double bond, carbon double bond, like that. Keep on drawing. How much big carbon chain you can draw? You can draw very big, isn't it? Like that, no other atom can go with this catenation except carbon. Silicon forms compound with hydrogen which have chain up to 7 or 8 atoms. So silicon also can go with catenation, but only with 8. But these compounds are very reactive. The carbon compound or carbon-carbon bond is very strong and hence stable. So carbon-carbon bondings are very stable and very strong. It is not aggressive, it is not reactive, etc. This gives us large number of compound with many carbon atoms linked with each other. So catenation is the property possessed by the carbon. So it is versatile. So one reason we have found it out. Second, Since carbon has valency 4, it is capable of bonding with 4 other atoms of carbon or other atoms of other monovalent element. What is monovalent element? If there is one valency, it is known as monovalent. Example, hydrogen valency is 1, lithium valency is 1, but it will donate, don't take lithium. And chlorine valency is 1, hydrogen can combine with chlorine, HCl can be formed, and carbon can be combined with chlorine, right? And carbon can combine with hydrogen. Like that, monovalent elements it can combine. Why? Because it has 4 valency, and that 4 valency is known as tetravalency. Okay. Compounds of carbon are formed with oxygen, hydrogen, nitrogen, sulfur, chlorine, and many other elements, giving rise to compounds with a specific property depends on element other than the carbon present in the molecule. So it can form with some other elements, but a property is depending on other elements instead of carbon, so that only there is no that much properties related to carbon. So carbon property will not come into the limelight. Other elements which are sulfur, nitrogen, chlorine, that properties will be coming up. And again, bonds that carbon form, the most other elements are very strong, making else compound exceptionally stable. One reason of the formation strong bond called carbon has its small size. Because of the small size, that carbon can bond with different elements. So valency 4 is also known as tetravalent element. Carbon is tetravalent element. Now in examination, if they ask you why carbon is versatile, 2 points you can write. It can possess process of or property called catenation. Number 2, carbon can combine with many elements because carbon is tetravalent element. Enough, you can leave it. Next, node of this carbon compound, let us try to understand saturated and unsaturated compound. Then we are in topic saturated and unsaturated. Now itself we have understood saturated means single bond, unsaturated means double and triple bonds. Now we have already seen the structure of methane. Methane structure is CH4. Another compound formed between carbon and hydrogen is ethane. So what are those names? What is methane? What is ethane? Why it came? Okay, let us try to understand simple thing that I'll explain you now. Saturated and unsaturated carbon compounds, let us try to understand now. I'll complete this topic within 10 minutes. So we have understood saturated in the sense it is single bond, unsaturated means double or triple bond. Now basically this saturated and unsaturated are divided into 3: single bond, double bond, triple bond. So single bond means, you know, between carbon there will be one line. Double bond, between carbon there will be two lines, means two bonds. Between carbon, three. Now single bond, we will try to understand in next lecture regarding that chain homologous series. Homologous series, I'll explain you. Meanwhile, just to try to remember three names. First one is alkane, not AT, alkane, alkene, alkyne. Alkane represents homologous series of single bond. Alkene represents homologous series of double bond. Alkyne represents homologous series of triple bond. Just names. In next lecture, definitely I'll tell you. Just remember. Now, here this alkane, alkene, alkyne. So what we have understood regarding compound and carbon compound? We know compound is nothing but if there are two or more atoms combined, we can call it as compound. What is meant by carbon compound? Carbon compound is nothing but if one of the atoms is carbon and remaining are different atoms, we can call it as carbon compounds. We have another compound that is hydrocarbon compound. So three compounds, understand: normal compound, carbon compound, hydrocarbon compound. What is hydrocarbon compound? In a compound, if you find only hydrogens and carbons, that's it. There should not be any extra atom, no oxygen, no chlorine, nothing. If you find hydrogen and carbon in a compound, that is known as hydrocarbon compound. Now we need to discuss about hydrocarbon compound which has homologous series. Now alkane, alkene, alkyne are three homologous series. Alkane means single bond in hydrocarbon compound, single bond in hydrocarbon compound. Alkene means double bond in hydrocarbon compound. Alkyne means triple bond in hydrocarbon compound. Next, there should be only hydrogens and oxygens, isn't it? Now we have to take count of hydrogen. Sorry, not hydrogen, carbon. Count of carbon. We have to count number of carbons in homologous series. We have to count number of carbons in homologous series. How to count? If you have one carbon, we have to call it as meth. Two carbons, eth. Three carbons, prop. Four carbons, but. Not but, it is but. Five carbons, it is pent. If it is six, we can call it as hex. In your 10th class, you have up to 6. Meth, eth, prop, but, pent, hex. Write this in your running notes. And if you want, you can take screenshots too, such that we can calculate number of carbons, number of hydrogens by using few formulas. Now, what we have discussed, alkane, alkene, alkyne. Let us see. Alkane, alkene, alkyne. So, guys, alkane, there is a formula CnH 2n plus 2. I'll tell you what is that. Alkene CnH2n, alkyne CnH2n minus 2. In place of n, substitute natural numbers like 1, 2, 3, 4, 5, 6 and so on. If you substitute 1 in alkane, it will become C1H 2 into 1 plus 2, that is nothing but C1H 2 into 1 2, 2 plus 2 4, C1H4. If you substitute 1 in alkene, it will become C1H 2 into 1 2. If you substitute 1 in alkyne, it will become C1H 2 into 1 2, 2 minus 2 0. Basically, this molecule is not formed. It is not possible. Why? We'll discuss in our next lecture. This also not formed. Why? One carbon with no hydrogens means carbon with 4 valencies, it will be waiting to get stable. So this is also not possible. Now, tomorrow lecture, in next lecture, we'll discuss how to write these formulas, how to name these formulas, how to draw structures for these formulas. We are going to discuss in our next lecture. Meanwhile, you try to write this one in your classwork or running notes. If there are one carbon, if there is one carbon, you have to call it as meth. And of course, extension is there. If it is alkane, you have to go with methane. You see, eth, we have 3 names. Ethane, because alkane, alkene, ethene, alkyne, ethine. For propane, propene, propine, butane, butene, butine, pentane, pentene, pentine, hexane, hexene, hexine. We'll discuss this with formulas in our next lecture. And meanwhile, you can take screenshot of this or you can write this in your classwork. That's it in this lecture.